In this video, we're going to cover the basics of external validity and sampling methods. Validity represents the truth, accuracy, or correctness, and becomes very important for research studies because we're often trying to know what is the truth so we can apply it to patients we see in our practice. There are two forms of validity. The first form is called external validity, which is the degree to which quantitative results of a study hold true in other circumstances or for other people outside the study. Sometimes this is referred to as the generalizability or the applicability of study results. The second form is called internal validity, which is the degree to which the results of a study are correct for the group being studied, or how accurate are the results of the study for those people that are actually in it. As a consumer of research, you must always assess the validity of a study. That's why you're in this critical appraisal course, so you can learn how to do this and apply the results to your practice. In order to assess the validity of a study, you must examine threats to the study, which usually come in the form of different biases. Biases are systematic errors that can be reduced by proper study design, sampling, and data collection methods. When it comes time to implement research evidence into your practice, you will want to read the study and determine whether the authors have done enough to control for bias in the study design or in the way that they control the study design afterwards in terms of statistical methods in some cases. And that will give you information as to whether you allow the results to be believable or that you believe the results can be applied to your practice. It should be acknowledged that sometimes certain biases are unavoidable or too costly to completely control for, and at that point, the decision is in your court. You have to make a judgment as to whether you're going to use it or not. If we focus on assessing external validity of a paper, you're tasked with answering a simple question. Can you generalize the results of the study to people outside the study? For example, those patients in your practice. You have to use some level of judgment to determine if the phenomenon under study is likely to be generalizable, and to what groups can you apply that results to. The way research studies work is that we have a population in mind, often a specific condition or patient group, and we want to know if something is effective for them, or we want to know more about a specific risk factor, for example. But we can't study everyone in the whole world. We don't have access to them. So we try to define something called the accessible population that we could study. For me, that might be all the people who've had a stroke in childhood and live in southwestern Ontario. That's the population that's of access to me that I can actually physically do research on. Even that population, though, is quite large, and it could be costly, time-consuming, or very difficult for me to complete the study if I was to try and get every single person in southwestern Ontario who had a pediatric stroke into my study. So I take a sample of that population, or a smaller subset of those individuals, and I study them, hoping that the results can be generalized back to the accessible and target populations. The process by which we go from a target population to that smaller sample is known as sampling or selection. And there are many different ways to do this. Some of these ways present opportunities for bias to creep into our study. Probabilistic or random sampling methods are used to randomly select subjects for participation in studies, and it's the method most likely to capture a representative group of eligible subjects or have the lowest chance of bias being present. Remember, bias is not completely avoidable, so it's never a guarantee. The most basic probabilistic sampling technique is called the simple random sample. In this method, each element or person in our stroke example has an equal chance of being included in the sample. Each person is assigned a number, and the numbers are randomly drawn until your sample is complete. This could be as crude as putting all the numbers into a hat and drawing them out, or as sophisticated as using a random number generator and picking them off your list. Systematic random sampling involves organizing potential participants according to a specific identifier. So this might be their patient account number in the hospital. And the first person is then selected randomly. And then you create a rule that allows you to select the remainder of the sample based on their numerical distance from that first individual, i.e. every 8th person. Stratified random sampling is a more complex probabilistic sampling method, and you use it when you have an interest in capturing subgroups equally within your population for things like sex, age, or severity status. In this case, you create distinct categories or subgroups that someone belongs to, and that would be according to that important characteristic that's of importance for your study, and then randomly selecting people from each subgroup using one of the methods that we described earlier, either simple random sampling or systematic random sampling. Finally, cluster random sampling can be used when studying something is linked to an extraneous factor that someone belongs to. So in the case where each selection is then a group of people because the focus is on the unit they belong to, for example, a school, a family, or a neighborhood. And then everyone that belongs to that school, that family, or that neighborhood would be targeted for enrollment into the study. Non-probabilistic or non-random sampling refers to methods for choosing subjects that do not provide every element or every person in the population with an equal chance of being selected. These methods are easier to use, particularly in clinical research where there may be small populations or access to patient populations is limited, and they're often less costly, but the absence of random selection increases the opportunity for a sampling bias. It's less likely that a sample drawn using these methods will be fully representative of the population of interest. The most basic non-probabilistic sampling method is called convenience sampling, where investigators take anyone that is eligible for the study through methods like email or poster advertisements or approaching patients in a specific clinic. Often this method involves enrolling all patients that agree consecutively. Investigators rely on participants to become spontaneously available from their identified sources. Quota sampling is a convenient sample with some guarantee that you recruit a certain number of individuals with specific traits of interest, such as age or sex, in an attempt to make the sample more representative or more diverse, so that you're not just stuck with kind of whoever shows up in the clinic that day. Snowball sampling is a technique where investigators start with a few subjects and use those subjects to help recruit more individuals into the study through word of mouth. This can be particularly effective for small populations or populations that are hard to identify. For example, individuals experiencing homelessness or very rare genetic conditions, because often these individuals that experience these characteristics know other people who experience those characteristics as well. Finally, purposive sampling is an approach where investigators actually hand-pick subjects due to specific traits. Investigators make specific judgments about which individuals are appropriate and then enroll them so that they actually have potentially covered multiple characteristics that they've deemed are important. And it's very popular in qualitative studies, not so much in quantitative studies, because by handpicking individuals to be in your study, you're potentially biasing the results. Regardless of how the sample is drawn, the characteristics of the sample should be compared to the population of interest to see how representative it is. This will guide you in your ability to apply the results beyond the population studied in the study. And that is our external validity of the study. So you need to judge the target population, the sampling methods, the reasons people decline to be involved in the study if they're reported, and the characteristics of the subjects that were actually recruited to be able to make a judgment about the applicability of the results to your practice and to your specific patients. To do this, most studies will provide you with a Table 1, or usually the first table in a study. And this is the demographic characteristics of the subjects that were actually enrolled in the study. I've provided an example Table 1 for you here. Let's zoom in on GMFCS level. This is a scale that represents functional ability the functional ability capacity for people with cerebral palsy. If I compare it to a known proportion of children in a neuromotor clinic in Alberta, I can see that the study wasn't entirely representative of the population of that clinic. It oversampled individuals in level 3 and 4 and undersampled individuals in level 1. This might have been on purpose, as individuals at level 3 and 4 experience more functional limitations, and so their perspectives may be more important to capture depending on the topic under study. The same thing can be seen for distribution of involvement. In summary, there's no right answer to external validity. It comes down to the purpose that you're going to be using the research for, who you're applying it to, and do you have confidence that those clients are like the individuals in the study enough that it'll be generalizable to them. It's all your judgment.